The competition tasks in the Maritime RobotX Challenge have been designed to mirror those involved in real-world USV research and deployment.
Many problems exist that require innovative approaches to solving, including navigation, obstacle avoidance, observation and search, and automatic docking.
The technical directors have done their best to include all of these into realistic scenarios that will test even the strongest teams.
The real-world applications we were thinking of when we designed the course were basically centered around the types of things unmanned systems would need to do in the real world. So we thought about, if we're looking for surface craft for boats, essentially, do you want it to park itself? Do we want it to drive around, avoid obstacles, maybe obey the rules of the road, obey when navigating on channels? That's the type of thing we were looking at when we designed it, and all these tasks are based around those basic behaviors.
We tried to create a tiered approach for some of these tasks, where some of the early tiers are easy for a lot of the teams to get, and then with the teams that have the more developed algorithms and the more developed sensors, they can kind of go a little further in depth with those tasks and answer a little bit more to get some more points. One challenge that we had a little fun with was the LED's observe and report task to that LED buoy. So once they report an answer to that task, that buoy will explode on screen, and then the team's flag, country flag, will be displayed on the buoy for a good 10 or 20 seconds to show how they captured the flag by successfully answering that challenge.
It's really about the students. They're the key to this. We want to get them excited about it. I started in a competition very similar to this years ago, and I want to give back. I'd like to be able to see them get excited about it the same way I did, and also see them work together, learn, build this community of unmanned systems experts and people who can do this down the road, and develop the technology, take it to the next level, really.
The first challenge is made up of 2 pairs of buoys that act as gates. The boats must autonomously navigate through these. This is the only mandatory task in the competition, so no other points can be scored until this task is completed.
A real-world task that robot boats could assist with is searching for a device under the water, such as the black box from a downed aircraft. In the second challenge, the boat enters a search area with 4 colored buoys, 1 in each quadrant. Beneath each is an acoustic pinger. Only one is active. The boat must locate this pinger and report back its buoy color, position, and depth under the water.
Third is the autonomous docking challenge. The robots have a choice between 3 different docking locations, each identified by a unique symbol. The robots can score points by parking in any stall, but major points are awarded to robots that can identify and park in the stall corresponding to the symbol of the day.
For an unmanned vessel to be trusted with missions out in the ocean far from home, it must be able to observe and report back what it encounters. In the fourth challenge, a special buoy has been constructed that flashes a colored light sequence. The robots need to observe that color sequence and report it via a transmission back to base.
The final challenge deals with obstacle avoidance. The robots must enter this section of the course through a specific start gate. They must then navigate around the obstacle buoys and pass through a specific exit gate. Avoiding all the obstacles results in maximum points.
All of these challenges add up to a complex and difficult mission for a robot boat to accomplish fully autonomously. Keep checking back here for highlights and recaps of how the teams are doing at robotx.org.